In question 1, we're considering Gandalf, who paces back and forth. He starts at position 0 at time t equals 0, and he moves one step forward or back at each time step. And for example, in question part 1, we want to consider how many different paths he can take if he returns to his initial starting place, 0, at t equals 6, and it is his first time returning to his starting place. So for this question, we'll set up the following notation, where this line represents Gandalf's starting place. And for example, for one of the paths, he could go forward, 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 then back, back, back. Another option for his path is for him to go forward, forward, back, forward, back, back. Notice how in each of these he has 6 steps because he has exactly 6 seconds to take his trip. And he returns to his starting position only at the end of his trip. So now we have 2 such candidate paths, and for each path, actually, we could have gone backward instead of forward. So each of these gets a times 2 multiplier. If you just simply switch the definition of forward and backward, if you want to think of it like that, or just think of him heading east instead of west. So in this case, there are 4 paths that he can take if he returns to 0 at t equals 6 and it is his first return. For part 2, we want to know how many paths Gandalf can take if he returns to 0 at t equals 7 and it's his first return. What we saw from before is that we had an even number of steps, both forward and backward. So every time he took a step forward, he had to later take a step backward in order to return at 0, which means that he needed some number of steps divisible by 2. But 7 is not divisible by 2 since it's odd, which means that there are actually 0 paths which will allow him to return to 0 at t equals 7 at any point, regardless of whether or not it's his first return. So the answer to part 2 is 0. For part 3, we want to know how many paths Gandalf can take if he returns to 0 at t equals 8 and it is his first return. So we'll use the same notation that we had in part 1, where this is the starting line. So one of the possible paths is for him to go forward 4 times and then back also 4 times. Another solution, similar to what we saw in the first part, is to go forward, forward, backward, that's 3, forward 4, backward 5, forward 6, backward 7, backward 8. And so there's yet another one. Each of these will be times 2 for the same reasons mentioned in part 1, because he could have gone backward, 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 then forward, 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 for example, for the first one. So there are 2 candidates. There are a couple more. So I'll just start another line here. For example, he could have gone forward, 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 backward, forward, backward, backward, backward. He could have also gone forward, 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 backward, backward, forward, backward, 1, 2, 3, 4, 5, 6, 7, 8, backward. And then finally, he could have done, and each of these, by the way, will have a times 2 multiplier. And then the final option is to have gone forward, forward, backward, forward, forward, backward, backward, backward. Again, we have 1, 2, 3, 4, 5, 6, 7, 8 steps. And this one, as all of them do, will have a times 2 multiplier. So we see that we have 2, 4, 6, 8, 10 possible paths. So the answer for part 3 is 10. For part 4, we want to know how many paths Gandalf can take if he returns to 0 at t equals 2n plus 1 for any n in the natural numbers, and it is his first return. So as we saw in part 2, it is impossible to return to, there are 0 paths if t is an odd number. So 2n plus 1 is guaranteed to be an odd number. Therefore, there are 0 paths for part 4. Now we want to look at how many paths Gandalf can take if he returns to 0 at t equals 2n plus 2 for n in the natural numbers, and it is his first return. So it's suggested that we go read the Wikipedia page on Catalan numbers. So let's go take a look at that. What we see first is that the nth Catalan number is given by 1 over n plus 1 times 2n choose n. And if we scroll down to applications in combinatorics, we see, for example, that the nth Catalan number is the number of words of length 2n. It's a string consisting of n x's and n y's, such that no initial segment of the string has more y's than x's. So for example, the following are words of length 6. We see xx, x, y, 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 which looks very similar to one of our paths from part 1, if we say the x's are forward and the y's are backward. But then we see, for example, x, y, x, x, y, y, which would be a path of forward, backward, but now we're at 0, and it's too early. We're supposed to return to 0 at t equals 6 and no sooner. So if we illustrate this, for example, this would become the path forward, backward, forward, forward, backward, backward, which isn't valid. However, if we modify it slightly and we say, okay, we're going to put a forward in, then we'll take this path, forward, backward, forward, forward, backward, backward, and now we need a backward to counter our first forward. Now this is a correct path. So we see that words of length 2n can be used to give us a path 4 that is length 2n plus 2. So we have cn equals n plus 1, 1 over n plus 1 times 2n choose n paths, except that we can go forward or backward as our first step. So we could reverse what x and y mean. Maybe x means forward or backward and y means the opposite. So we have a times 2 multiplier. So our number of paths is actually 2 times c sub n, which is 2 over n plus 1 over 2n choose n.